So what we'll do now is we'll kick off with our next presenter, Andrew Whitlock from Precision Agriculture. Now Andrew's background, he's an ag science student from Melbourne Uni, and he began his career with Department of Primary Industries as a statewide precision agriculture agronomist. And from there he's worked both nationally and internationally, and he's also been recognised as Young Agronomist of the Year back in 2006. He now works closely with a range of farmers and agronomists to implement site-specific crop management, particularly throughout Victoria, Tasmania and southern New South Wales. So on that note, I'd like to thank Andrew. Thank you.
Sure, wonderful. Thanks Yasmin, and thanks to Marcus Oldham for the opportunity today. Today, do you want to get that talk up please? Beautiful. So today I want to touch on the area of precision ag where it meets the farm, so mainly focusing on application. Our business has been around since around 2009, and we work with around about 600 farmers all over Australia, predominantly Eastern Australia. Majority of those farmers are grain production, and today I want to talk about some of the key technologies that are working on those farms, because the stuff that Dave spoke about is fantastic, and there's an enormous amount of growth in this area. It's a real boom. It feels as though precision ag's been the top topic for quite a long time now, yet if you look at the numbers of who's actually implementing site-specific management actions, so taking it down to sub-paddock level variable rate type activities, it's around 10 to 15%. So some great information. A lot of farmers are using steering, of course, auto steer. 80-90% of farmers are using that. However, when we get to sub-paddock level, really low adoption. So today my talk's about some of the things that we see that it's working well for those farmers that are going to sub-paddock. And predominantly it's around understanding your soils and how they vary across a paddock. So often the first discussion is, well, why bother? You know, there's all this information, but why would you try and generate a map that looks something like this for a paddock? And the simple answer is when it makes sense to do so. So Lemmy was talking before about, you know, that local knowledge and understanding of your paddocks. You know your paddocks better than anyone else, and so when you've got country that you know varies from, you know, the most obvious is in the Mallee region, where you've got sand rises and clay flats. Absolute no-brainer. They haven't been farming a single rate application on that country forever. Any farmer who's doing that's probably would have gone broke 100 years ago. So it makes sense to do so. So it's about coming into those areas where it's a little bit less subtle, more subtle. And I think most farmers know, and it won't be every single paddock, but you'll know there'll be certain areas on your farm where you've got quite a lot of change in soil type, and therefore it might make sense to start getting some accurate soil maps and start thinking about some vari-rate management on that. And you know it's going to be worthwhile because you not only do you understand, you see, you feel, you've got different soils, but it's also relating to production. You're seeing it on yield maps, just walking through the crops. You know whether you've got variable production across paddocks. Irrigation is a big one. So most irrigation farmers, or many irrigation farmers, are looking at this path of understanding soil water holding capacity, how it varies across a paddock, and trying to target water accordingly. Again, makes sense. Really simple. Massive investment in that small amount of farming area, so want to maximise productivity. So doing a fair bit of work in that space. So I suppose they're the main times when it makes sense to do so. What we want to do is try and really understand these key soil constraints, and that's where we see most of the work, or most of the benefits is coming down that path of where farmers are helping develop strategies to improve soil health. And I view it as like having a healthy platform for your farm. You know, a lot of farmers have moved down to this path of minimum till and stubble retention and diverse crop rotations, and it's all about having healthy soils and sustainable farming practices. And I think setting a platform where you've addressed sodicity and acidity, salinity, waterlogging, these type of issues, I think that's another one of those things, in my mind, it's just like a tick box. You need to make sure you've got those issues addressed. And if you've got the presence of those types of issues across the farm, and they do occur variably across paddocks, it makes sense to try and map them out. And it might not be, all your country. In fact, rarely would it be. You would need to map the entire farm to implement this. It'll be on certain areas. So the types of actions we're talking about. So the most common soil map you would have heard of is an EM38. It's a measuring conductivity of a paddock. So that measures conductivity down to about 1.5 meters. It's quite a good way of understanding textural changes across paddocks. So once you've got that map and you've implemented some targeted soil cores in those different zones, EC zones, then we can start looking at operations such as vari-rate irrigation of water holding capacity. Nitrogen, however, that does need to be linked in with some other production data, and I'll touch on that a little bit later on. Because some applications require more than just understanding soil properties. We need to link that back to what's been happening historically with production. Variable rate gypsum is, we're missing some slides here. Gypsum, changing seed populations across different soil types. Again, if you know you've got areas where you struggle to get the required plant population, looking at different rates of seeding is an obvious one. Potentially crop rotations. Lupins might be better on certain soil types than beans, and so thinking about how you might change your rotations according to some of these maps. Pest control, so slugs, this part of the world, slugs on those sort of more cracking soils. Again, linking that in with production data. If you were smashed with slugs the year before, might make sense to up the bait just on that part of the paddock the following year. Other actions, drainage, obviously, elevation maps, so quite a wet year in large parts of Australia. So thinking about drainage plans off that soil data. pH mapping for lime, we've been doing that since 2010, and it makes a lot of sense, which I'll touch on later, and some of the nutrient mapping for phosphorus and potassium in particular. So they're the types of actions that we're commonly seeing across farms up and down the East Coast. How do we go about it? So I guess there's two different types of, the way I see it, there's two different types of soil mapping technologies. Those that I'd consider sort of direct and indirect. So the direct are those that have got a really clear understanding of what the critical levels are. So direct testing of pH to determine a lime requirement, for example, or measuring Colwell P to understand how much phosphorus you need, how much super to put out across the pasture. Quite linear in the measurement and the application. The indirect are those where we look at like it's a surrogate map. So an EM38, understanding conductivity. Well, conductivity alone, we can't use the conductivity number and convert it straight into an action. We need to go and ground truth it and understand, high EC, what's it mean? It could be salt, water, high clay content, and then what's the action from it? So there's a few more steps to be required to get to that action. And I think it's these indirect measurements that a lot of people talk about for a long time in precision ag, and I think this is why we haven't seen the mass adoption, because there almost needs to be a leap of faith between I'm going to go and spend $10, $15 a hectare, generate a soil map. I'm not 100% certain at this stage what my action is going to be, but I'm going to do some ground truthing and try and figure out what the benefits will be from there. So you almost have to be a leader in that area and just have a real passion for precision ag and say, I'm just going to go and do it because I believe in it. So they're the early adopters. We're now talking about the mass market that are coming through, and I think we need to know, if you're going to invest in that $10, $15 a hectare to do this work, you want to know with a fair bit of confidence that you're going to turn that into $50 a hectare. And so that's where some of the more direct measurements have their fit, I believe. So some of the indirect measurements are spectroscopy. So you may have heard about, and this is a really exciting development where particularly in labs, but we can also get these tools in the field. And so we can scan and look at the reflection of a soil from a ground up sort of soil sample, and it can give you a whole range of predictions of how that soil is going to function and what the nutrients would be, organic carbon, texture, pH, the whole lot. So that will change the way, I believe, particularly labs. Instead of spending $100 to get a comprehensive soil test, you'll be able to run it through a spectroscopy machine and do that for $10. But it is predictions, and we still need to link it back to wet chemistry, all the traditional sort of. So that requires thousands of wet chemistry samples to run through to build the predictions for different soil types. But once you've got confident predictions in a certain region, with a lot of confidence, you can start using those predictive numbers out of spectroscopy. EM38, as I mentioned before, and gamma radiometrics, which is more in the sands over in Western Australia, where EM's not as accurate. So they're good guides to tell you surrogate maps of what might be happening across the paddock, but you still need to go and do that sort of ground truthing to and link it in with a measurement with a known critical level. So we see paddocks like this, for example. This is one of those examples where it makes sense to do so. Interestingly enough, we were asked to go and sample that paddock, and the agronomist had given us a transect to sample it, and the transect basically ran right through the paddock, one transect. And he's been looking after this country for years and years, and we weren't prepared to sample it that way. So we said we have to get smarter, and hence David's whole philosophy on smart farming. That does not make sense at all. So the farmer reluctantly said, I'll spend an extra $200 or whatever it was to get those couple more samples. On lime alone, he saved $2,000 on targeting the lime application just off those transects. It just makes sense, but not every paddock's that easy. So some country, you can do it literally off Google Earth. You don't have to spend any money, don't have to get the EM38 in to go and map it. You can just do it because it's that obvious. There's a lot of cases where it's not quite, you understand that the variability is there, there's a need to manage it, but you might need some other information to identify where these different zones are, to delineate where those different areas and change need to be. And once you've identified these zones, setting a professional sampling plan or a set sampling plan, and that becomes your sampling plan forever. You're confident in that might be where you go and do soil pits, put moisture probes. Certainly when you're soil testing it, how often do you soil test a paddock? 4 or 5 years or whatever it might be. They're the points you constantly go back to. And so like at each of those points you might do 5 cores. All that goes into a bucket, so you've got one number that represents the yellow area, for example. I just think we need to, if we don't go to this level for soil testing and we just do the transect through the paddock, we're going to continue to make misinformed information and decisions on fertiliser rates in particular. Complete waste of time testing it across there. Not all paddocks need this, and I'll reaffirm, I'm not here just to jam that down your throat that you have to be doing vary rate in every paddock. No, you don't. The single rate is suitable for lots of country, but it's those paddocks where you've got that transitioning soil type. I think you need to consider going down this path and understanding it. So it's all about how do you then delineate? What do you use to delineate those different zones? I've mentioned this already, the EM38. And there's also another machine, a Veris machine, which runs cultures through the soil and again measures conductivity. Been around a long time, work well if done at the right moisture conditions. So you need to make sure that when you're doing it, it's at a time when you've got consistent moisture across the paddock. If you don't do that, then it'll be a water map. So the high readings will just because you've got higher water in the paddock. And we're actually using that to our advantage up in the north around Moree and in southern Queensland, where we can generate a soil water map. And then from that, because they grow crops on stored water, they can actually think about a yield potential off that stored water and look at a vary rate nitrogen prior to planting when they put their anhydrous gas down and do the vary rate nitrogen off stored water. But down in this part of the world, I think if we do it at the right time, ideally sort of drained up limit, just coming out of winter, if we can get on the paddocks, go through and map it, generate an accurate conductivity map, and then go and do our targeted sampling and understand the different soil properties. So here's an example for a paddock over just south of Rokewood. So not too far from here. This is an elevation map that was collected at the same time. Red is high, blue is low, waterway through here. So this next to it is the EM38. So red is low, so these numbers are lower up to almost 500, which down through here we haven't tested it yet, but we've got a suspected salt issue at depth is what we believe down through this part, and so the next step for this, so we've got some 0 to 10 soil test results, and it's a little bit hard to read, but this area through here is lower lying. there's a need for some drainage, and we've got organic carbon of 3.5. So if we get that right, mineralisation and productivity should be quite strong, whereas up on the ridge here, our coal well Ps are quite low. Organic carbon's back to, I think, 1.7. So quite significantly different soil types in this 70 hectare paddock or thereabouts. So from that sampling, there we go. So we were able to identify where to go and do some soil testing, number one, to get our calibration and get our critical level numbers. We were able to identify where some drains will need to go, and it's coming out of pasture and into a cropping phase, and so what fence line was the best one, and that was mainly thinking about paddock layout and how to interface with those drains. So I think EM38 is a good way of delineating zones, getting a base level soil type, and start thinking about a whole range of different actions from that, as listed there, but also maybe some fertiliser plans. We also have been doing quite a lot of direct sampling, where we're splitting paddocks up into grids, and we're doing a physical soil test for every grid. So we look at running a transect, so we break it up into these little grids, typically 2 hectare grids, and instead of doing a transect through the paddock and doing one soil test, in a paddock here we're doing 60, what have we got there, 64 I think it might be, soil tests across that paddock to understand the properties we're measuring. So these are the 3 most commonly we're looking at doing soil pH and phosphorus at the same time, and then understanding how it varies. And we saw Dave had an example of a phosphorus map up earlier. So typically we're seeing really significant savings by going down this path of measuring, more accurate measurement, because the technology is there to implement that. The variable rate controllers can do that, no worries at all, on their spreader. So this is sort of what it looks like. We set a series of points. We collect a set of sub-samples within each of those regions into a bag, off to a lab, and then digitise it to generate a surface sort of pH and phosphorus map. So this is some examples of what they look like. So this year, this current year, we've conducted around about 40,000 hectares throughout this part of the world and up into southern New South Wales of this sort of top density sort of grid-based mapping of pH, and then generating that into an associated lime map. So this is an interesting one. This is that same paddock I showed you before with the EM38, where the pH didn't necessarily correlate exactly to the EM38. It did. This area here where we think we've got some subsoil acid issues, saline issues, sorry. This was quite high. So this had a pH of 7 in calcium chloride, and other areas were down to 4.3, where these areas were requiring up to 4 tonne of lime. So in this paddock, if we were to take a traditional approach and say we'll put a tonne to the acre of lime out, normally coming out of a pasture phase or prior to every canola phase, and that's a fairly robust sort of typical rate, we would have been under applying lime on the majority of that paddock and putting lime on an area where we don't need it at all, and we're potentially pushing pH levels up high, which is going to start interacting with some issues with herbicides and breakdown. So on balance, we need 2.6 tonne to the hectare to lift that paddock up to a pH of 5.2. So we haven't saved anything, and then in fact, if you were going to use the traditional rate of 2.5, we're asking to put a little bit more on, but we know we're delivering rates that are actually going to achieve what we need to do and be confident. So I think it's all about confident decision making. Phosphorus and potassium maps for that same paddock. Again, I showed you before we had a coal well P of 12 from the sandy areas, and then coal well Ps of, I think it was about 30, 32 and high 20s through here. If we look at the grid map, it makes sense why you would have reached those nutrient values from the zonal sort of testing, but the grid-based testing has given us a lot more, I suppose, granularity to that paddock and then to the decision making. And so, coal wells from as low as sub 10s is and up to 80, 84, and a lot of that's around. There's a gate sort of through here, and there's comments from the farmer is, potentially stock camps influencing that. So I think there's a value in doing this sort of work in pastures, but also, the cropping phase as well. So the plan for this farm will be to use a cropping rotation to build up our phosphorus areas, use this process to put out lime and phosphorus, build it up, and when we do sell it back to pasture, we know we'll have certainly a better situation than only 14% of the paddock at that optimal phosphorus level. You can use the plants, and David spoke a lot about looking at imagery, and we've been using, we've processed millions of hectares of satellite imagery over the years. I think it normally just tells the farmer what they already know. It puts some spatial context around it. The real challenge is to then convert it into an action rather than just being, that's nice and interesting. So I think, again, if you've got an issue, you want to implement some sort of action and you want to just use the map to delineate these zones, this is where we can do it. And so this is a farmer in central Victoria, and you bought where satellite imagery, the red's low biomass. The farmer, they didn't have to do any ground truthing, they knew straight away that's the area. This is an irrigation farm, and so where they'd cut and filled, so the cut areas are the low biomass. So we were able to convert the cut, those zones into an application map, which was a background map that went onto the John Deere. So on the John Deere, as you're driving on the John Deere tractor, in the background would be this map, and so implemented strategies such as gypsum, manure and deep ripping just on those blue areas. Also looked at different seed rates through there when I sowed canola, and made a tremendous difference to canola but also to the corn production. So, thinking about understanding soils, we can also let the plants be another indicator to develop those strategies. Nitrogen management is a big one, and it's often the first discussion that we have with farmers that they want to get right. It's the biggest spend, we know that. It's challenging, because we've got so many interactions with the soil and seasons. So the first question I ask farmers is, so I think there's two strategies with vari-rate nitrogen. One is, can we predict nitrogen plans at the start of the season? So do you typically have areas of the farm and soil types with inherently low nitrogen where you might need some higher nitrogen levels at the start of the season? And then so yes or no, and how do those zones look? And then it's what happens later in the season on yield potential and as the season unfolds. So if we've got variable water, holding capacity, significant potentially yield potential varying across paddocks, then we should be able to think about some variable rate nitrogen. Keeping in mind that a nitrogen plan in a zone will change in time if you start implementing other actions to fix it. So if you start taking out some other constraints, then so this is where the comment here is, a lot of people look at a lot of yield data and say, well, let's look at the last 10 years yield maps, we'll do some yield stability, and they are going to be my production zones. I think you need to be careful with that, because if you start fixing some of these underlying constraints, get the platform right, though some of those spatial trends across paddocks will change, and then your nitrogen strategy will need to try and change with it. This is an example of a farm in Inverleigh where yield maps have been seeing quite a lot of variability on the yield maps. Did some EM38, confirmed what the farmer did know, that but put some really clear line around where that heavier clay was. This is really quite sort of black clay, where about a third of the farm, where one end of the farm's pretty well sand, other half's clay, and there's where it meets is where we've been doing this mapping, just to accurately identify these paddocks that have got that need different zones. So sand and clay, that's the zone map for that particular paddock. Elevation doesn't tell us anything; it doesn't relate to elevation. So we're developing nitrogen strategies around these deep end soil tests at the start of the season, but also as the season unfolds, particularly through strips trials, so nitrogen strips. And you can see here we've been doing a few trials. This was a few years ago. The clay got waterlogged in that particular year, and the more nitrogen we put on, there was no response. Ultimately, we want to get to a point where we understand response curves to those different zones and how phosphorus and nitrogen and different inputs sort of vary. But a fair bit of work, and this is where the on-farm R&D has to come in to help develop some of those management strategies and understand likely response rates. So the early nitrogen strategy is about delineating these zones of different soil types, doing the calibration testing. Have I got lower nitrogen? If I have, let's make sure we're getting some more nitrogen on early, because I strongly believe that the first 3 months of the crop's life, if we can give it a really good, if we can sow on time or early, the 2 times or so I believe, give it a good chance and a good strong plant, it's going to be more robust to handle things that potentially can happen to it later in the year, like waterlogging or a tight finish. So I think this is where we can look at some strategic soil testing. What are our levels, vary rate, nitrogen, and potentially seed rates on those zones. As the season continues, then we start thinking about understanding water holding capacity and yield potential and how that might vary across a paddock. And this is where you do need to start getting into some crop modelling, I believe, and running the likes of yield profit and doing some of that testing, which some of you may be doing on the farm. I think it makes a lot of sense if you want to go to this level, but it's a whole new level of commitment that still not many farmers are doing. And then the other thing is thinking about nitrogen, looking at how the season's unfolding from a biomass point of view, and this is where some of the nitrogen-rich strips can come in, looking at trials. We've got some farmers that will have a nitrogen trial on every single paddock, and we'll be looking at 2 or 3 captures through the year of satellite imagery to just track when are we seeing a response to help gauge when that paddock's starting to be responsive to N, and therefore help determine when you might actually want to start putting more on the rest of the paddock. Challenge with imagery is, what do I do if I've got this map? Do I put more nitrogen on my poor area? Because that might not be a nitrogen constraint, that might be another constraint, that more N won't be the answer at all. So again, ground truthing, gut feel, experience has to come into the play. Typically, though, for most guys in the higher rainfall environment where we typically work, it's about trying to maximise yield potential. And more often than not, people want to push those lower biomass areas a little bit harder. This is an SOA, sulphate of ammonia map we did last week for a farmer in northeast Victoria. Just went and patched out those areas with 80 kilos on those sandy areas of the paddock. Spoke about nitrogen strips. This is some work we did with Southern Farming Systems quite a few years ago. I think people can get mixed up with these sort of strips saying, well, I would never put 200 kilos of N out, that's not what I want to do. But I don't think that's the aim of a strip. The strip is purely just to say, is this paddock N responsive, and then you need to bring it back to what your target yield is and your soil N level. So I just think they're a really good visual clue to help with that really quite complex decision. So I think it's about being confident in what you're doing on the farm, using soil maps and soil measurements to inform and have these sort of information-rich decisions made. Make sure it's with proven science. I think we need. I think too often we try and throw out the basics and all the learnings and the stuff ups we've made, and we try and be too cute. I think we need to focus on the core information that to implement your vary rate strategies. And start with the paddocks that are most variable, and you don't have to do all of it. Start with a few, look at the return on investment. If it makes sense and it's working for you, continue to explore across the rest of your farm. Thank you.
Thank you, Andrew. That's very in-depth about precision ag, and I'm sure there's some questions, but I am just going to hold off on the questions because we've got a break now. But I just want to mention that after lunch, Andrew and some of his work colleagues have brought up an ATV, and we'll give a bit of a demo somewhere outside in that vicinity. So that would be a good time to also catch up with him if you've got any other questions as well. So what we'll do now is break for morning tea, and that will be a 20-minute break. So I'll be calling you in about 15-20 minutes. Thank you.